Hi everyone, uh, welcome to Rakesh sir lecture, and today we are going to discuss about visual acuity in context to visual optics. So we are going to see the optical aspect of visual acuity. So this outline of this lectures will be importance of visual acuity, few terminology related to visual acuity and its recording, how we'll document visual acuity, and then limit of visual acuity. It's like optical limit of visual acuity and the neural limit of visual acuity. So this all lectures will divide into three parts. For easier purpose, first I will divide this from importance till this recording, visual acuity and its recording, in one lecture, and then optical limit of visual acuity in other second lectures, and neural limit of visual acuity will be in third lecture. Okay. Coming to the exams point of view, importance of visual acuity and till importance, few terminology, and visual acuity and its recording will be asked mainly in 2 marks questions. Like each will be asked in 2 marks questions. And once you come about optical limit of visual acuity, will be asked in essay questions. And once you come about neural limit of visual acuity, it will be asked again in essay questions. Okay, so coming to the importance of visual acuity, but before I starting the importance, I assumes like at least you know some basic about visual acuity. At least you have heard about the visual acuity, right? So in simple term, if I want to define the visual acuity is the amount. It is a quantification of vision. So it is a quantification of vision. How much you can see. If I want to quantify it, right? Everything we need to quantify it, right? If you're going for shopping, if you're buying vegetables, you need to quantify it, right? So when you want to quantify vision, we'll document in the form of visual acuity, right? So it is a quantification of vision in simple word. Anyway, we'll go in detail about later. So what is the importance? What is the importance of quantifying it? Or what is the importance of visual acuity? So what do you think? You can think like you want to categorize the people who have good vision and who has bad vision. For that, or who has poor vision. So to categorize the people who has good vision and who has poor vision, you have to take visual acuity, right? So first you can write like to categorize the people who have good vision and bad vision, or we can tell as poor vision. Okay. Anything more importance? Later upcoming lectures I'll be talking about the refractive error. So in that time we need to wear either glasses or we can add some other mode of correction. So when you have a refractive error, so to correct the refractive error we need the help of visual acuity, because the betterment or improvement of visual acuity will determine how much amount of lens will give. So for the correction of refractive error we need the help of visual acuity. So for the correction of refractive error, right? What will it have? You know, vision is a broad term. So if you want to quantify the vision, you can write in the form of visual acuity. So for the quantification of vision, right? And the visual acuity also be tested when you want to diagnose pathological condition of eye. So for the diagnostic purpose of ocular pathology, we need to take vision, right? Not only diagnostic. When you want to monitor some ocular conditions and disease conditions, you need to monitor the visual acuity to monitor their disease progression. So to monitor their disease progressions, we need to check visual acuity, right? If someone is having glaucoma, and you want to see either and you give the medical treatment or surgical treatment, and you want to know either the vision is decreasing or increasing. So if vision improves, that means disease progression improvement. If vision is constant, means at least the disease is constant, it is not deteriorating, right? So based on the if the vision drops, that means the disease is getting worsened. So based on if you track the visual acuity, disease progression can be monitored. So for the monitoring of disease progression, right? Any other use where we need a vision? Some occupations like military, pilot, right? So they need the medical checkup, and for them they need the good amount of vision. So for the medical checkup, checkup in few occupations, right? For eligibility purpose, for the medical checkup to be eligible in few occupation like pilot, right, military, etc. Any other uses are there? We have listed out almost 6 uses, right? There are some more uses actually. If some patient come to your clinics with some emergencies, like met with accident and some bleeding was there, and it is like ocular emergencies, and it's urgent required for the surgery, and that time, what do you think? Do you check vision or directly you send for surgery? You think if you directly send for surgery, and after surgery, if the vision has been deteriorated, or the patient lost his vision, or vision is decreased after the surgery, then patient complained that before the accident the vision was good, or before the surgery the vision was good, and after the surgery the vision decreases. So how will you differentiate this? So whatever the emergency is there, you first check the vision, at least document it. So if you have documentation, we can show that okay, before the surgery the vision is this much, because we don't know, once he met with accident, that time only the vision has been gone. Maybe after surgery it cannot be recovered. So that may be the case, but for that the proper documentation should be there. So visual acuity should be documented well enough, whatever the emergency is there in, right? So for legal purpose, so you will not end up with some legal issue and all. So for legal purpose, you need to document the visual acuity. Any other uses? Any other importance? Our government has provided some benefits for low vision and blind persons, right? So for that, if you want to categorize someone is low vision or blind person, you need to check vision first, right? So first to provide the certificate for low vision and blind person. So for certification of low vision and blind, for certification of low vision and blind, are you getting it? Any other? Okay, this was more than enough. So these are the importance in which we see that visual acuity will be checked, right? And we should not skip. So coming to, before really going into the deep of this visual acuity topic, I want to highlight few terminologies so that it will be easier for us to go through the lecture in the further classes. Okay, so the terminology used here is MAR, and that is called minimum angle of resolutions, and one more terminology is called visual angle. So two terminology we are going to discuss, and third terminology will be visual acuity itself, right? So first we are going to see about visual angle, and what is visual angle, and what is minimum angle of resolution. It's very, very important. Without understanding the concept of visual angle and MAR, it's you cannot understand visual acuity actually. So let's understand the concept. So first I'll keep here visual angle. visual angle VA. Visual angle. Do you have an idea what is visual angle? It plays a very important role in optical instrument. When you are checking the microscope, there they will increase the visual angle, right? Telescope, they are increasing the visual angle. So visual angle, it is the angle subtended by object to the nodal point of the eye. So that angle is called visual angle. So if the visual angle is more, you can see the object clearly. If the visual angle is less, it is difficult to see in detail of the object, right? So let's first draw with diagram to understand it better what is visual angle means, right? So here this is, what is this one? Eye. This one is cornea. Let's assume this one is total eye, and this is the scleral plane, right? Scleral plane, sorry, retinal plane. And this is the optic axis of the eye, okay? Optic axis of the eye. And let's assume this is an object, right? This is an object of height AB, and this object, when it is and you know, just posterior to lens you have nodal point. Posterior to lens you have nodal point. So once this object is passed, see, light refraction, when the light is passing, it is assumed to pass from the nodal point of the eye, okay? So here AB, so image formed on the retina will be A dash and B dash, A dash and B dash, and this is the height of the image. And the angle subtended by this object, see, listen here carefully, attention please. The angle, this angle sustained by this object, this angle is known as visual angle. So angle subtended by this object on the nodal point of the eye, so such angle is known as visual angle. Are you getting this? Yeah. So now, how much this angle should be minimum? See here, understand the concept of angle. It's very simple. Visual angle is simple. You take any object, you draw from this and pass the light, make the light to pass through this nodal point of the eye. You make an angle, that angle will become the visual angle. Okay, it's very simple. Okay, but the main concept what we have to understand is MAR. About MAR, minimum angle of resolutions. What is minimum angle of resolution? First we'll learn it conceptually, then we'll go for the proper definitions of MAR. So MAR is, the word itself is minimum angle of resolution. That means if these two objects can be seen resolved, that means two objects can be seen they can be seen as two. Let's assume this is marker, okay, and this two marker, if I'm separated by this distance, so this can be seen at 2, maybe at from a near distance. But if you go so far, you cannot separate it 2. It will become, it will appear as 1. It will perceive as 1. So that means there is some resolution point, or that means when you are near, they are forming some different angle. When you increase the distance, when you go far, they are forming some different angle. So this two markers can be seen as 2. That is, there is some locha between angle. So there is some threshold of angle below which it can be perceived as, below which it can be perceived as 2, and below and above which it is perceived as 1. You are getting it? But that means there is some cutoff value. We'll go in detail about this. Okay, so MAR is, there is some minimum angle. There is some minimum angle, if you, below which it cannot be separated as 2, it will be as 1. Okay, and if you go beyond that means below that, this MAR will, no, that threshold is called as MAR. That threshold, the angle of threshold. I'll not play this things, and just let me explain in the diagram. So In human eye, in context to human eye, the minimum angle of resolution is 0.8 minute of arc. 0.8 minute, and as you know, 1 degree equal to 60 minute. You know, the 1 degree is so small, right? In that, if you do 60 part, you will get 1 degree. Sorry, 1 minute. 60. 1 degree equal to 60 minutes. You know about 1 degree, how much less it is. Like with circle, if you just point 1 degree, how much less it will be 1 degree. And out of that 1 degree, you make it 60 part, you will come 1 minute. Okay, and if your object is subtending that 1 minute also, that is enough. Like I can able to resolve it and separate it, and you can see it to marker as 2. Okay, so that means approx it is 1 minute. It is even less than that. Ideally speaking, it is 0.8 minute of arc, but for the calculation purpose, you can write it 1 minute of arc, right? So here now, this visual angle, if it becomes 1 minute of arc, if it is become 1 minute, now it is 2 degree. Let's say 2 degree is more than enough, right? 2 degree is 120 minutes, and 1 minute is enough to resolve it, right? If it decreases it further, if let's assume this height is up to here. Second case, we are taking the height is up to here. That means the angle will be decreased, right? And this angle became now, let's assume 1 minute. Okay, so 1 minute, still it can be resolved. Still you decrease the height. Lesser you decrease the height. Now what happened in this case is, you can make up to here. Okay, so this theta, let's assume that this is 1 minute of arc. This is 1 minute of arc. So 1 minute. Okay, so in this case now, this object can be, let's assume this is object E, like this way. Object, it is letter E. Are you getting it? This letter E. I can make it in this way, letter E. Letter E. Okay, so this letter E, that means the limb, the upper limb and the lower limb, they are making 1 minute of arc, but still you can resolve it because it is the threshold below which you cannot resolve it. You cannot see E as E. Maybe you see something else, E as C or E as something else, right? So, but if it is 1 minute of arc, if this letter E subtends 1 minute of arc in this nodal point, still you can perceive this as E. But below which, if it comes like 0.5 minute of arc, right? 0.5 minute, 0.4 minute, 0.2 mm, 2 minute of arc. So that time you cannot resolve it, and you cannot perceive this letter. You cannot see that letter. Okay, so in human eye, but if we take it for eagle's eye, you know, the surface point of vision, they can resolve up to 0.2 minute of arc. So that means if it decrease further also, the eagle can see and resolve it separately. They can see in detail, right? They can see how many limbs are there, what is the letter this about, up to 0.2 minute of arc, right? But of course, we are unlucky. We have in human eye, we have up to 1 minute, or more specific, it will be a 0.8 minute of arc. So of course, we can resolve up to here. And this threshold of angle, where this visual angle, this is one visual angle only, right? This object, listen carefully. This object, letter A, is subtending 1 minute of arc, or 1 minute of arc at the nodal point of eye. So this object is subtending some angle at the nodal point, right? So this is called visual angle. But it is subtending 1 minute of arc, and 1 minute of arc in case of human eye, it is called as minimum angle of resolution. You are getting it? One more thing I want to explain. MAR will differ from species to species. I'm telling, if this is 1 minute of arc, if the visual angle is 1 minute of arc, in case of human beings or in case of human eye, it should be called as MAR, minimum angle of resolution. But if you take the same case for eagle, E-A-G-L-E, right? E-A-G-L-E, eagle. So if you take the same case in the eagle eye, this in eagle eye also, if this it is subtending from the object subtending at the nodal point, this angle is called as visual angle. In eagle eye also it should be called as visual angle. If it is subtending 1 meter of arc also, it is called as visual angle. But this 1 meter of arc should not be considered as MAR, minimum angle of resolution for eagle eye, because it can resolve more in detail up to 0.2 minute of arc. So in eagle case, if this angle decreases further, if the height decreases further, and if it is making 0.2 minute of arc, then such visual angle in eagle eye, it should be called as MAR. So visual angle, anything which is subtend, any object which subtend angle at nodal point of eye is visual angle. But if that angle becomes 1 minute, then for human eye it is MAR. If that angle becomes 0.2 minute of arc, then for eagle eye it is MAR. So minimum angle of resolution will vary depending upon species to species, right? I hope I am clear about MAR now, right? So what is MAR now? For proper definitions, you can write it. It is the minimum angle of resolutions below which the object cannot be resolved, right? Or the two lines cannot be seen as two, right? Below which the two lines cannot be seen as two. So such minimum angle is known as minimum angle of resolution. So it's worth to maintain. Minimum angle is nothing but it's a visual angle, one case of visual angle. It's one subclass of visual angle. But why it is so I am emphasizing on this MAR? Because the next terminology is about the topic, what is here? Visual acuity. And visual acuity is reciprocal of MAR. See, mathematically, visual acuity is defined as reciprocal of MAR, minimum angle of resolution. So it is very, very worth to repeat this. So before I go this way, first I should tell you how will you document visual acuity. How will you document visual acuity? So recording will be done in several format. The first format, common format, is Snellen format. And in Snellen format also we have two types. One is 6 meter format, so 6 by 6, okay, 6 by 6, it is a normal vision. It is considered as a normal human vision, 6 by 6. So this is called a 6 meter format. Same things can be expressed in 6 meter equal to 20 feet. So 20 by 20 format, 20 feet format, okay. So this is one format. You can write in the form visual acuity can be write in the form of fraction, and this fraction can be 6 meter format, or this fraction can be 20 feet format, right? Other is we can write in the form of decimal format, okay, and even you can write it in the form of logmer format for research purpose and all, or for minor change in visual acuity. If you want to monitor, you can do the logmer format. Anyway, we will have detailed lecture on this logmer format. But as of now, trust me, we are going to see more about Snellen and decimal format and how it works. Logmer will have a different lecture on this, okay. And one more lecture I will be having how to convert this visual acuity from one form to another form, okay. So I can add here one more lectures on how you can okay, that will have different lectures actually, okay. So separate lectures can be done for conversion of visual acuity from one form to another form. Now, if the visual acuity is 1, what does it mean? It is normal vision. You have good vision, normal vision. So 1 means visual acuity is 1. That means MAR will be how much? So if visual acuity is 1, reciprocal of C here, MAR put here, this 1 will let it be 1 by 1. So visual acuity will be, so MAR will be 1. So when you subtend 1 minute of arc, you will have MAR. When you subtend 1 minute of arc, your visual acuity will be 1. So one is a decimal format of documenting decimal format. Okay, so that means when you are subtending 1 minute of arc, you will have maximum vision of 1. You have maximum vision of 1. So that means you have normal vision of 6 by 6 by 6 is 1, 20 by 20 is 1, right? So this 6 by 6 or 20 by 20 is considered as normal vision. Why can't we see more in detail than this, better than this? Why our vision is not like 6 by 3 or 20 by 10, right? Why our vision is not there? Who is restricting this vision? Why we can't see? Have you ever thought why our vision is not better, like as like eagle, right? Or what is restricting? What is the anatomical features, or what is the optical parameter which determines your vision is limited up to 6 by 6 or 20 by 20? So that will see in the lecture of optical limit of visual acuity and neural limit of visual acuity. So these are the two main parameter which determines how much why we are restricted up to see up to 6 by 6 or 20 by 20. Okay, before this, so we have completed importance, the terminology like visual angle, MAR and visual acuity. Okay, one more things I want to highlight here. There are some types of sense, types of vision sense. The types of vision sense, it will be asked in 2 marks actually. Types of vision sense. So out of one sense will be the visual acuity. So let me first write what are the types of sense here. One, or what are, this is types of vision sense, or it also be called as types of perception, types of visual perception, types of visual perception. So if it is asked, you can write first is, or one is, we have form sense. We have form sense, and this form sense will, when you are able to find the details of any structure, that is called as visual acuity. So other way of defining visual acuity is, it is one type of form sense perception. It is one type of form sense visual perceptions, right? Similarly, we'll have color sense. It helps to distinguish from different types of color, right? Then we have contrast sense. And yeah, so color sense, contrast sense, that means we can, when the contrast is changing, you can feel that there is no even border between that, but even within the same color, if slight change in the contrast can be perceived by our eye. So that is called as contrast sense. Okay, so these are the sense we have to know. So mainly I want to focus, there is one more type, but anyway, so there is I want to focus on this form sense. We are going to see more on form sense. So this form sense is visual acuity. Okay, later we'll be going in detail about color and contrast, but okay, as of now we are talking about the visual acuity. So we have completed importance, few terminology, types of vision sense or types of visual perceptions. So, and then we are going to see about visual acuity and recording, how, like already completed visual acuity, what is visual acuity and how the recording will be done. So coming lectures will be discussing about the optical limit of visual acuity. Before I end the lectures, I want to specify few things about visual acuity. Mainly I want to talk about eagle. Eagle has sharp point of visions. The one parameter is the cell density, the retinal cell density is more, very more. We have cone density in fovea is 2 lakh cone cells per mm², per mm². In 1 mm², we have 2 lakh cone cells, that too in central fovea. If you go periphery, then okay, that cell density will decreases, right? But if you come to if you talk about eagle, they have more than 10 lakh cone cells in the fovea. That means their cell density, cone cell density, retinal cell density are very packed, are very more. so they can see more in detail. Okay, so their limit of resolution is more. Limit is more, but number is less. It can the angle, minimum angle is 0.2. So even it can resolve up to 0.2. So first things you have seen in the eagle eye, what is there? They have 0.2 minute of arc, so the vision is better. First things, their cell density is so retinal cell density is so high, so they can see anything in detail, object in detail. If they are seeing the face, they can see each detail of the face. Okay, if they want to capture a fish or a snake or something, they can see how it is moving in detail. You're getting? So because of the cell density in the retina is very high, like almost more than 1 million cell density in per mm square, per millimeter squares. But one more interesting fact is there. How many fovea we have? Macula or fovea? We have only one, like temporal to optic disc, right? But eagle has two fovea. Eagle has two fovea, and because that makes eagles to have sharpest vision in two directions. Even the eagle can see the other way, and the other fovea is looking at some other, because two fovea is there, right? So one is seeing towards somewhere else, and one is seeing toward the prey where you want to capture, right? So prey thinks like, okay, the eagle is seeing somewhere else, but one fovea is continuously surfing toward that eagles. So when it feels like, oh, this is a good time, it will go and catch it. But we can't do that. Even we are seeing, we can focus only in one object, because other subject we can see, but not in detail. We can see peripheral vision, we can see, but not in detail. But these things will not happen in eagle. They have two foveas, so one they can even the peripheral fovea have the same sharp point of vision, right? So this makes the eagles to have better depth of perceptions, because two fovea is combined. So when the brain perceives, they have good depth of perception. Not only this, you know how much axial length of our eye is? We have 24 mm approx. Eagle has 34 to 36 mm. So when this axial length increases, right, that means the size of the retina eyeball is increased. So that means when the image is formed, it is formed, larger retinal image size is formed. So when the larger retinal image size is formed, the things can be seen very clearly and sharp or in detail. When you have magnified image, we can see the things in detail, right? So because of the increased axial length in eagle, the eagle can see the things in detail. So these are the few points. The eagles have sharper vision as compared to us. The first point what we have discussed, eagle has 0.2 MAR. Eagle has, because of MAR, they have good visual acuity, and eagle has two fovea, right? Axial eagle has 1 million, more than 1 million cell density per mm square, and eagle has larger axial length as compared to us, right? And this is one thing I just want to convey apart from our this lecture. Yeah, it's good to know sometime, right? So so we'll continue the optical limit of lecture in the further lectures. So if you feel this lectures is informative and useful to you, please do like, share and subscribe